kangaroo hops 2 kilometers in 3 minutes. At this rate, how long does it take the kangaroo to travel 5 kilometers? And how far does the kangaroo travel in 2 minutes? For this problem, I set up a table to show that it takes 3 minutes to run 2 kilometers. Okay. It doesn't matter. I could have put kilometers first and then minutes and then switch the information. I would get the same results. So I'm going to remember that with the table, this means 3 times some number equals 2. I will rewrite this as 2 divided by 3 to get my rate, which is 2/3, which is 67/100. Okay. So now what this tells me is this number, however many minutes it is, I'm going to multiply it by 67/100, and it's going to equal 5, because in a table the rates are the same. Okay, so to answer question A, some number times 67/100 equals 5. So there's my equation. Some number times 67/100 equals 5 kilometers. In my calculator, I would put 5 divided by 67/100, which equals, let's see, I'm going to put it in my calculator, 5 divided by 67/100. It's a long decimal, so I'm going to shorten it by putting 7 and 46/100. So I'm going to round to the nearest hundredth. So what that tells me is it takes almost, well, really I could round that to 7.5. Let me do that instead. Okay, I'm going to round that to 7.5 minutes, about 7.5 minutes to go 5 kilometers. Okay. All right, for question B, how far does the kangaroo travel in 2 minutes? Okay. Because of this relationship, I would do 2 times 67/100. So 2 times 67/100 equals, let me put it in my calculator, 1 34/100. So in 2 minutes, the kangaroo can hop 1 34/100 kilometers. Alright, question 2. May runs around a 400-meter track at a constant speed of 250 meters per minute. How many minutes does it take May to complete 4 laps of the track? So I went ahead and set up my table. I have minutes to meters. It tells me that's 250 meters per 1 minute. How many minutes does it take for May to complete 4 laps? The information given to me was not in laps, but a track would be, like if you think about the track at our school, 1 lap around would be 400 meters if the track is 400 meters altogether. So 4 laps would be 400 meters 4 times, which is 1,600. So on my table, I'm going to complete this by putting 1,600 meters. Alright, I know my relationship that 1 times 250 equals 250. So whatever this number is, if I multiply it by 250 meters, it's going to be 1,600. Okay, so that helps me to see that I'm going to do 1,600 divided by 250, which equals, let me put it in my calculator, 6 4/10. So it would take 6 4/10 minutes to run 1,600 meters, or 4 laps. At 10 o'clock a.m., Han and Tyler both started running toward each other from opposite ends of a 10-mile path. So that's how far apart they are. Han runs at a pace of 12 minutes per mile. So when Han starts walking this way, and he has gone a distance of 1 mile. It has taken him 12 minutes. In part A, it says, how far does Han run after a half hour and after an hour? So I'm going to take this information just for Han and put it in this table. 1 mile is 12 minutes. Okay. Half an hour would be 30 minutes. An hour would be 60 minutes. Okay. So I have my rate. 1 times what number equals 12? Was 1 times 12. So all of these would be times 12 on my table. Okay. Alright, so now I have my equations. Some number of miles times 12 would equal 30. So I can rewrite that multiplication statement as division. This would be 30 divided by 12, which equals 2.5. So in 30 minutes, Han will have traveled 2.5 miles. Alright, same thing here. Some number of miles times 12 would equal 60. So I'm going to rewrite that as 60 divided by 12, which equals 5. So it would take Han would go 5 miles in 1 hour. Because remember, 1 hour is 60 minutes. And half an hour is 30